Welcome to Brunda Engineering Academy. In this video, we will discuss about how to resolve the number of forces. How to resolve the number of forces acting in a system. That means if in the system we have two forces, then we can find out the resultant magnitude and direction by using the parallelogram law of forces simply. Whereas if in a system number of forces are there in this way, then how can you calculate the magnitude and direction of the resultant force? So here this is the diagram shows the problem. So we have to calculate the magnitude of the resultant, that is R equal to, you have to calculate. We know the basic relation R equal to sigma h square plus sigma v square. It is the basic fundamental equation. Whereas direction theta equal to tan inverse of direction theta equal to tan inverse of sigma v by sigma h, theta equal to tan inverse of sigma v by sigma h. So to solve this type of problem, you have to remember these two expressions. R is the magnitude of the resultant force, theta is the direction of the resultant force. Before going to the solve the problem, I will simply two conditions. If the force is acting while calculating horizontal forces, sum of the horizontal forces, you have to decide the force in the right hand direction or left hand direction. Right hand direction or left hand direction. If the force is acting in the right hand direction, you can take it as positive sign. If the force is acting in the left hand direction, you can take it as negative sign. Next, while calculating the sigma v, that means algebraic sum of the vertical components, you have to decide the force is acting in the upward direction or the force is acting in the downward direction. If the force acting in the upward direction, you can take it as positive sign. If the force acting in the downward direction, you can take it as the negative sign. These are the basic things you have to remember. While calculating sigma h, you decide the force is right or left only. You don't worry about the upward or downward. Next, sigma, while calculating sigma v, you have to decide the force in the acting in the upward direction or in the downward direction only. Don't worry about the right hand or left. Okay. Now I will calculate sigma h for this type of problems. So first of all, I consider sigma h. I have considered sigma h equal to, coming to this one, first force 200 newtons. So 200 newtons, 200. The force is here. I am calculating sigma h. The force acting in the right hand direction. Observe the arrow mark. The arrow mark shows in the right hand direction. So positive sign. Next 200. It is the horizontal component. For a horizontal component, this is the force F. Assume the force F. It makes an angle theta. The horizontal component is F cos theta. Horizontal component is F cos theta. The vertical component is the F sin theta. This explanation is given in the previous videos in our channel. For that, you can refer our Brunda Engineering Academy channel. Now, sigma h equal to 200 newtons. What is the horizontal component for 200 newtons? 200 horizontal component, 200 cos 30 degrees. Okay, next 250 newtons. 250 newtons is acting in the upward direction. You may take that 250 also, but 250 newtons. The angle is how much? This angle is 90 degrees. What is cos 90? Cos 90 value 0. Cos 90 is the 0. So that entire term will become 0. That's why while calculating sigma h, vertical components will be negligible. So This will be the negligible. Next, coming to 300 newtons. 300 newtons arrow mark left hand direction. So left hand direction means you take it as negative. So 300. What is that? Three horizontal component for 300? That 300 newtons makes an angle of 45 degrees with the horizontal. So 300 cos 45 degrees. 300 cos 45 degrees. Next, coming to the 350 newtons. 350 newtons is acting in the downward left hand direction. So that is also negative. So 350 cos, what is the angle of inclination with the horizontal? That is 350 cos 40 degrees. So these are the different forces in the horizontal component system. Horizontal component. Now, this 200 cos 30. What is that 200 cos 30? 200 cos 30 degrees is 173.20 minus 300 cos 45. That is 212.13 minus 350 cos 40 degrees. Then it will become 268.11. So by the simplification, you can get this sigma h as 173.20 minus 212.13 minus 268.11. Then you get the negative value, that is 307.04 newtons. Next, coming to the sigma v, all vertical component, algebraic sum of the vertical components. So first 200 newtons. 200 newtons will be acting in the upward or downward? Upward. So upward 200 newtons. 200 newtons upward direction. So it has positive sign. And what is the vertical component? So f sine theta. So 200 sine 30 degrees. 200 sine 200 sine 30 degrees. 200 sine 30 degrees. Next, coming to this 250 newtons. So 250 newtons simply vertical. So upward direction. So plus 250 newtons. You may take it as that is sine 90 degrees. So sine 90 value is already 1. Next, coming to the next force, this is 300 newtons. 300 is the upward direction. Upward direction and angle of inclination is 45 degrees. So upward direction, so it is 300 newtons sine 45 degrees. 300 sine 45 degrees. Next, coming to the next force, 350 newtons. That is downward direction. Then 350 sine 40 degrees. 350 sine 40 degrees. So now by the simplification, you can get by the simplification of this entire equation, 200 sine 30 degrees plus 250 sine 90 plus 300 sine 45 minus 350 sine 40 degrees. Then you get the value 337.15 newtons. Now, what is the magnitude of the resultant? R equal to sigma h square plus sigma v square. Then you can get square root of sigma h is minus 307.04 whole square plus sigma v 337.15 whole square. Then by the simplification, r equal to how much you get? 307.04 square plus 337.15 whole square. Then the square root, you get the value of 456.01 newtons. So it is the magnitude of the resultant force for this type of problem. Next, coming to the Direction having the relation theta equal to tan inverse of sigma v by sigma h. So then tan inverse of sigma v, how much? 337.15 by sigma h minus 307.04. Then by the simplification, we get theta equal to 337.15 by minus 307.04. This for this tan inverse, we get minus 47.67 degrees in the negative direction. That is nothing but 47.67 degrees. So in this way, we can calculate the magnitude and resultant for the magnitude of resultant and direction of the resultant for the number of forces acting in the system. You can simply remember these two expressions. R equal to square root of sigma h square plus sigma v square, theta equal to tan inverse of sigma v by sigma h. Next, while calculating sigma h, you can decide the force in the right or left. If that is the right side, then you can take it as the positive sign. If that is the left side, you can take it as the negative direction. While calculating the sigma v, you can take upward or downward. For upward direction, you can take it as the positive. For downward direction, you can take it as the negative. This is about the resolution of forces. And for this type of problems, one more model is also there. That will be discussed in the next video. Okay. Thank you. If you like this video, you please share and subscribe Brunda Engineering Academy.